In this video, you will learn how to graph nonlinear functions, including square root, cube root, and exponential functions. Let's first look at a square root function. You'll be required to determine the domain of a square root function before graphing. Remember, the domain is the x values of a graph. So in order to find the domain, you'll need to set the expression underneath the radical greater than or equal to 0. Because if you think about when you take the square root of a number for a square root function, taking the square root of a number, if it is negative, will result in an imaginary solution. And you can't graph imaginary solutions on a real coordinate plane. So we will need to restrict our domain to be greater than or equal to 0. So let's look at an example of a square root function. So we have f of x that is equal to 4 times the square root of 3x plus 18 minus 7. Now we're only going to find the domain of this function before we start graphing. So like we said, this 3x plus 18, just the part under the radical, would need to be greater than or equal to 0. If it's anything smaller, it's going to result in an imaginary solution, so we can't graph that on a real coordinate plane. So let's solve this inequality. We would subtract 18, so 3x would need to be greater than or equal to negative 18, and divide by 3, so x will need to be greater than or equal to negative 6. Remember, you only flip the direction of the inequality sign if you multiply or divide by a negative. We divided by a positive. So our inequality will stay greater than or equal to negative 6. We can write that domain as negative 6 to infinity. Because it says it's equal to negative 6, we would include a bracket. Infinity would only ever have a parentheses. This is called interval notation for the domain. Now let's look at an example so we can graph. Number 2. We're going to graph the function y equals the square root of x minus 1, and then on the outside of that radical we'll have a plus 2. So we are going to need to start with finding the domain so that we know what x values we could use for our graph. So what's under the radical, x minus 1, would be set greater than or equal to 0, and we can solve by adding 1. So this means that our domain is going to go from positive 1, it will include positive 1, all the way out to infinity, because it says it needs to go greater than or equal to 1. So all the way out to infinity would include those values. So when you make a table of values, we typically have 5 points when graphing nonlinear functions, just to make sure to get the nice curve shape. Here we will always start with our domain. Here is our x value of a positive 1. And it would be enough to have 4 points altogether. You could still do 5. So after we find our domain, we need to find the y values that go with that. So you can use your graphing calculator. You'll go and press the y equals button on the first row of buttons. Press y equals. Clear out anything that's in there, and also make sure your plot 1, 2, and 3 are turned off. If they are highlighted, then that means they're turned on, and usually that can mess up your graphing, so just arrow up and turn that off. So in your y1, make sure to type in the exact function you were given. So the square root, you go second square root of x minus 1. Be sure to arrow out of that radical before punting in your plus 2. So we'll go second table, and we had found that our domain needed to start at 1. So notice any numbers above 1, the y number says error, because our domain is restricted to being greater than 1. So we're going to start there with that point 1, 2, and then copy other points from the table. It is going to be possible that you'll have to graph some decimal values, but if you can find nice integer values that will fit on your graph, feel free to use those in your table. So I'm going to use 2, 3, 5, 4, and I'll pick at least one decimal, maybe here at 8, 4.6. So let's go to our graph. For example 1, and plot these points. We're at 1, 2, so x is 1, y is 2. Remember, that's your beginning point, so nothing will be left of that point. And then at 2, 3, oh, I miscounted the first point. Let me try that again. 1, and then up 2, and then 2, up 3. There we go. 5, 4, and 8, 4.6. So 4.6, I've counted up to 4, but 0.6 would be in between the 4 and the 5, but about halfway, because 4.5 is halfway. So 4.6 will be just barely halfway above. You can't be real exact as small as these graphs are. Just get it pretty close in between that 4 and that 5. You will connect with a smooth curved line. And it's always a good idea to check your graph with the graphing calculator. You just hit the graph button, you can see that it is going to match. I wouldn't recommend trying to graph from the graph screen. Use the table of values to get your points on your graph, but you can hit the graph button to match it. Let's look at our next function. This time we're going to graph a cube root function. So here we're going to graph the function y equals the cube root of x plus 3, and then outside that radical have a minus 6. The cube root function has the domain that's all real numbers, so it's not restricted to just greater than or equal to 0 under the radical. So we won't need to start by finding the domain. You can actually start by just finding the hk point in the function. So our hk point would be here, this 3 as your h, or rather I should say negative 3, because if we remember it actually needs to be opposite of what's inside the radical. So negative 3, and then this k as our negative 6. Always be careful, as I just messed up the a, you also should be, I messed up the h, you should also be careful not to mess up that h. So it's actually negative 3, negative 6. Take the opposite of what's inside the radical, and then you take the k value as what you see, negative 6. So this will be our starting point for a cube root function, just taking the hk from the actual function. This point can go in the center of your table, so I'll use the table on the graph sheet. Negative 3, negative 6. Because we're going to need points on either side of that starting point so we can graph the curved shape of this cube root. So let's go to the graphing calculator. Again, press y equals, clear out our previous function, and this time we're going to type in the cube root. So we press math. Math is below the green alpha key, so press the math, and then arrow down or use just the number key to pick option 4. You could also use option 5. That would just mean you'd have to put the index number in yourself. So using option 4, the index number is already there for you. So we're doing the cube root of x plus 3. Arrow out of that to do your minus 6. Do second table and scroll through the table until you find the ordered pair that is our starting point. So there is that negative 3, negative 6. If ever you're not able to find the point that you say is your starting point in your actual graphing calculator, Stop right then and see if you have a mistake. It could have been as simple as mislabeling your HK point, or sometimes go back to your y equals screen and see if you typed in the function correctly. So second table, we have found the correct HK point. It does match what we thought it should be. So we're able to copy some points from this table. Pick at least two that are smaller than, so I'm going to pick the -4, -7 ordered pair. Then I'm going to scroll and find some other nice points that will fit on my graph. I think my graph only goes out to 10, so I guess I'm going to have to do maybe this -9. -7, well, it says 7.8. That wouldn't round just quite yet because it's got the 1 after it. 7.8, -7.8. Notice -11, -8 would have been a nice point to graph, but it wouldn't have fit on your graph. So go on down the other direction and pick two numbers larger than your x. So we're here at -3, so let's pick the -2, -5. And scroll on down and get some other points. Let's see if we can get, yeah, we've got the 5, -4. That will fit nicely. So let's graph these points. 1, 2, 3, 4, 5, 6, 7, 8, 9. We need to go down 7.8. 6, 7. 0.8 would be almost to 8, so not quite there. So there's -9, -7.8. So our next point, 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 1, 2, 3, 4, 5, 6. And then -2, -5. And then finally 5, -4. So this is the correct shape for our graph. We do see these 3 points. They are not a line. Be careful when you connect them. They are curved shapes. So just curve out this way and as well as curve out this way. You should see this curvature shape in the center, and it's going to kind of flatten out as it goes either side. Again, hit the graph button so you can see and compare that to the picture of the graph. And you do see that curved shape there with our starting point in the center, and then it curves up and down off of that starting point. So it's always helpful, of course, to graph the starting point and then to graph the next points on either side, the very next one, to get that curved shape. And that was example number 3. So let's look at our final graph. This time it's going to be an exponential function. Just like cube root functions, exponential functions have a domain of all real numbers. So we will not need to find our domain like we did with a cube root function. We're going to graph the function that is exponential of f of x equals -2 times 3 to the x power. When graphing exponential functions, you can find the starting point by finding the y-intercept. In order to find a y-intercept, you can just let x equal 0. If you think about a graph, just a basic sketch of a graph, our y-axis and x-axis, if we want to know the y-intercept, a point on that y-axis, that would mean our x is 0 at that point. X would have to be 0. So if we plug in x as a 0, that's going to find our y-intercept. So let's do that with our function that we have here. Let's plug in a 0 to find our y-intercept, which is going to be our starting point. So we have f of 0. We're going to do -2 times 3 to the 0 power. Well, let's do exponents first. 3 to the 0 power, that is 1, using our exponent properties. Anything to the 0 power is 1. And then multiply, so we get -2. So for our y-intercept, our x number is 0. That's what we plugged in, as x is 0. And we found that our y number was -2. So that's going to be our beginning or starting point for our graph for a exponential, is finding that y-intercept. So this is our example number 4. This y-intercept will go in the center of the table. That way, again, we can get points on either side. Since the domain is not restricted, we do want that in the center of the table. Only square roots do you put at the top of the table because you only need one side of the graph. This one we need both sides of the graph from that starting point. So let's go to our graphing calculator. Of course, clear out what you had in there before. So this time we have -2 times 3. To raise it to an exponent, underneath the clear button is what's called a caret key. So you can raise it to the x power. So do second table and scroll through and find that ordered pair that we say is our starting point. It does match up 0, -2, which is our y-intercept. And so pick 2 numbers less than and 2 numbers greater than. It's best if you pick the immediately 2 numbers less and 2 numbers greater, because if you go too far out from that starting point, the numbers get very, very small and very, very large very quickly in either direction. So it is going to be required to do decimals, and that's okay. So -0.2, -0.7 when it rounds. Of course, we have our starting point, and then -6 and -18. So this 2, -18 won't fit on our graph, but it is good to still include it in our table. So let's take a look at what this graph would be. So -2, -0.2. So it's just barely below 0. So -2, -0.2 is barely below 0 there when you graph it on the coordinate plane. So now we have -1, -0.7. -0.7 is a little bit more than half. So again, between the 0 and -1, but not quite all the way to the -1. Now we have our y-intercept, which was our starting point, our 0, -2, 0 on the x-axis, -2. That point should fall on the y-axis because we said it is our y-intercept. 1, -6, and that gives us enough points to see our curve there. 2, -18 would be on down this way. Of course, it won't fit on our graph, and that's okay. If you want to go back and get some more points off to this side of the left side of the graph, you could do that. But here we'll connect them. And actually with exponential graphs, they kind of flatline eventually, so this graph technically would never cross over that x-axis of y being 0. So this way, again, curving and extending that graph there. So as we've been doing, we can compare that with the graph in the graphing calculator to see that it does match here. And here it's difficult to see on the graphing calculator. It looks like the graph just stops, but it does actually continue. You could zoom in to see it a little bit closer. The detail, of course, is not showing very well in that graphing calculator. So that is how you graph nonlinear functions. Keep in mind with square root functions, let's go back and see that graph. Square root functions, you start at the top of the table with your domain. Once you find your domain, we said that was at 1. We need to pick numbers greater than that. We picked 1, 2, 5, and 8. So find your domain and start at the beginning of the table for square root functions, because those only go in one direction when you graph them. For cube root functions, you'll find your HK point. That HK point will go in the center of the table, picking numbers to the left and right, or the less than and greater than side of that HK point. And then for exponential functions, you find your y-intercept, and again, picking points to either side, left and right, or less than and greater than to that.